In this episode, we're going to be exploring area. Learning this is important because you use the concept of area in your everyday life. For example, when you have to clean your room or sweep your yard, you consider how much area or space you have to clean. Area is also considered in many occupations such as construction. Our objectives: students will explore tiling of a plane using different shapes. Identify shapes that will cover a plane exactly and those that will not. Name and measure regions. Compute the area of regions shaped as rectangles and right-angled triangles. Solve problems involving area measures. Engage. Use one or more shapes to create patterns on rectangular or square sheets. You may work with a partner. Here are examples. Now it says, watch the online video tutorial on area and perimeter on your tablet or computer, then compose a song, game, and dramatization to show the difference between area and perimeter. Perform for your parents or class. Write down the facts you learned about perimeter and area in your notebooks or for display in your room. Here are some facts you may have learned in your activities. The area is the surface of the object or the portion inside the perimeter. The perimeter is the measurement of the distance around the object. Area is written in square units. Area may be calculated by multiplying length by width. Elaborate. Estimate how many 1 centimeter square units can cover the square, rectangle, and triangular regions below. Remember, the area is the region inside the perimeter. It is the surface of the shape. So I'm going to estimate that for this one, about 9 centimeters squared, about 12 for this one, and about 4.5 for this one. All right. Now, cover the surfaces with centimeter squares to test your estimation. So you would take a grid like this and place it over to see how many of these units cover that particular area. The square above this one has an area of 25 centimeters square because 25 squares having a length of 1 centimeter and a width of 1 centimeter cover the surface. So 1, 2, 3, 4, 5 this way, and then 1, 2, 3, 4, 5 this way, and 5 times 5 would give us 25 in all. Cut pictures of furniture from the newspaper and ask your parents to help you to make models of them from cardboard or other easy-to-use materials. Place the furniture on square paper and trace the outline of the rooms, including the bathroom and kitchen, on the square paper and record the dimensions. The dimensions are the length and width of the rooms. Find the area for each room by counting the number of squares that cover the surface. You can also calculate the area of each room by multiplying the number of squares on the length by the number of squares on the width. And here they have an example. The length, 10 centimeters. Let's go. 1, 2, 3, 4, 5, 6, 7, 8. So that's not the length. This is the width then. So they are considering this to be the length. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the length. And the width of 8. And they say area is equal to 10 times 8. And remember the units would be centimeter. So it would be 80 centimeters squared. Explain. Calculate the area of the shaded and unshaded portions of the polygonal shapes. So here we have shape A and shape B. We have two rectangles. So I can see that this one is a rectangle, but the outside one looks like a square. Okay, may look that way, but let's look at this. This is 12 and this is 10. So they are close. But remember the properties of a rectangle. We're going to have two sides that are long and two sides that are short. And this side would be longer than this side. All right. So we have 12 and 10 here, and then 7 and 2 here. All right. Same thing here. We have 20 and 16. And then on the inside, we have about 14 and 10. All right, let's go with this now. To find the area of the shaded portion, subtract the area of the smaller shape from the area of the larger shape. Oh, so that means we have to do two calculations. We have to find the area of the large shape first, and then find the area of the small shape, and then take the smaller area from the larger area. All right. So let's go with A. So we would say 12 times 10, that's the area of the larger shape. And then we're going to take away now the area of the smaller shape, 7 times 2. So 12 times 10, that gives us 120. And we're going to take from that 7 2's 14. And that would give me what? 106 meters squared. Let's look at B. So we have 20 times 16 for the large shape, this one, and 14 by 10 for the smaller shape. So 20 times 16 would give us 320, and 14 times 10 would give us 140. And when we subtract that, we get 180 meters squared. Let's extend. Pretend that you are a Gleaner page designer. Cut out articles and advertisements from newspapers and paste them on a blank sheet so that the maximum area is used. Note that the amount of money made by a newspaper company highly depends on the number of advertisements in the paper. So try to make as many articles and advertisements as possible fit the area. Use a combination of two-dimensional shapes to form three-dimensional objects and calculate the surface area of 3D objects created, or use drawing tools, word processing software, or any simple graphic software to construct three-dimensional objects from two-dimensional objects. For example, using squares from a word processing drawing tool to construct a cube. Ask your parent or teacher to help you with this technology. Evaluation. Find the area of the shapes below. So let's look at this now. We would have here 1, 2, 3, 4, 5 this way by 1, 2, 3, 4, 5. 5 5's 25. Let's look at this one. So we have 1, 2, 3, 4, 5, 6. So 6 of these here. And how far down does this go? 1, 2, 3, 4. 6 4 is 24. So that would be 6 in that row, and 6 more 12, and 6 more 18. 18 and 6 would be 24. Then 24 and 4 here, that would be 28. 28 and 4 would be 32, and 32 and 4 would be 36. So this one should be 36 units squared. So for the triangle, count all the whole squares that you have, and then add all the half squares that you see, and then you'll get your final answer. All right, so let's just pick up now with question 2. And we have those shapes drawn here. So we have this rectangle 6 by 4. And we know that the area of a rectangle would be the length by the width. And I'm calling the 6th side here the length, and this side the width. So 6 4s, and this would give us, let's swap colors here. and this would give us 24 centimeters squared. Let's see if this is true. So remember that area would be the what? That amount of square units that are inside the given shape. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Because this is exactly 6 units this way and 4 units this way. So we get 24 centimeters squared. Let's move on to this square. Here we have 3. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, which is the same as saying side by side, or 3 times 3, giving me 9 centimeters squared. So our next question says, number 3, how many tiles that are 30 centimeters by 20 centimeters can tile a room that is 12 meters by 10? Note that the units should be converted to the same. So here we go now. So we have some tiles and we have the room. So on this side we have the tiles, and the tiles are here. The room information is here. So 30 centimeters by 20 centimeters. And we want to see how many of those could fit into a room 12 meters by 10 meters. So let's, step 1, see what the area of this tile is. Okay, so that's the first step. We need to find the area of the tile. So it would be 30 times 20. Okay, so 30 times 20, and this would give me 600 centimeters squared. So place a 0 here, then 2 times 0 is 0, and 2 3s would give me 6. Do the same thing now for 120 meters squared. We'd multiply, to get that we would multiply 12 meters by 10 meters, and we get the 120. They say that the units must be changed to the same. Therefore, we can do 2 things. We can change centimeter to meter or meter to centimeter. So let's go with our Harrison's ladder of conversion. And we can say here, kick him down, mister, don't commit more murder. Kilo, hecto, deca, meter, deci, centi, and millimeter. So let's go with this side first, where I'm going to change from meter to centimeter. So I'm going down, so I multiply, okay, by 10 each step that I take downward. So let's go. So if I have 120 meters and I need to change that to centimeters, here I am at meter. So I'll go 1 step down, 2 steps down. So that would be multiplying by 100, right? So 120 times 10 would give me 1,200, and 1,200 times 10 would give me 12,000. I add a 0 each level I go down, okay? Which is the same as saying 120 multiplied by 100, all right? Another way of looking at this is to say, if 1 meter has 100 centimeters in it, so it's a ratio of 1 to 100, and I have 120 meters, I know that I have 120 here, and I need to find the unknown in centimeters, then I can find the cross product. So the unknown would be my x, and I would multiply 120 by the 100, and that would give me here. So it would be equal to, add on these 2 zeros. So now I would end up with 12,000 centimeters. So x would be equal to what? 12,000 centimeters. Okay. Another way of looking at it is to say I'm going to change centimeters to meters, which is going up now because I had 600 centimeters. Remember, we worked it out. We could say, boy, we have 600 centimeters here. All right. So I could change those 600 centimeters to meter so that I'd have the same units in the end. So if I had 600, I'm going up. So this time I'll divide. It will be smaller, right? So 600 going up, I would go 2 steps up. So in the end, I could be dividing my 600 by 100. Okay. And if I divide 600 by 100, I know that I would have 6. Okay. I'll have 6 here. If the ratio is 100 centimeters to 1 meter, and I have 600 and I want to find how many meters that would be equal to, find the cross product. So I would say 600 times the 1, that would give me 600 on one side, and the 100 times x, that gives me 100x here. Now if I want to find my answer, I would divide both sides by 100, so I get x on the left hand side. Okay, so if we do that, let's say 100 into 100, that these will cancel each other out, and then 100 into itself 1 time, and 100 into 600 6 times, and that is how we end up here with x being equal, let's change this, with x being equal to 6 meters. Okay, so we have done our conversions and we have 6 meters. So for the meters, we have 6 meters to 120 meters, or 600 centimeters to 12,000 centimeters. So we have to make them the same. Okay, so for calculation purposes, that's what we're going to do. So meter to meter now, 6 into the 120, and 6 into 120 goes 20 times. Okay, and for the centimeter to centimeter, it would be how many times can 600 centimeters go into 12,000? And we divide by 100 here, divide by 100 there, because we often say 0 cancels 0, and we have 2 zeros here that would represent 100. So it's 100 into the numerator, 100 into the denominator, and we would end up again with the same setup here, 120 divided by 6, and 6 into 120 goes 20 times. Therefore, our answer will be the total number of tiles, 30 by 20 centimeters, to tile a room 12 meters by 10 is 20. So let's move now to number 4. It says find the area of the shaded portion. Let's think about this. To find the area of the shaded portion, 1, find the area of both figures. So if we notice that there's a larger shape here, a larger figure, and a smaller figure, we need to find the area of both. Then we need to subtract the area of the smaller from the larger. So let's go through with this. So let's find the areas of these shapes now. So for the first one, 5 by 5, that would give us 25. The smaller one is 3 by 2, that would give us 6, and we're going to subtract those. And then we're going to say 25, and we're going to take the 6 from it, and that would give us 19. Okay, so the area should be 19 units squared. Okay, so let's just put units squared here. So 19 units squared, and let's see if that is so. If this is 5 units, I'm hoping that this is large enough that you can actually see the little lines that are going through. So we have 1, 2, 3, 4, 5 that way, by 1, 2, 3, 4, 5 down. So we should have 25 in all, and then 1, 2, 3, 4, 5, 6. So that proves that. So the area of the shaded portion now, let's see, 1, 2, 3, 4, 5. I have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, so we can count it again. Let's see if we can put the dots in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Let's go with this part B. So we need to find the area of the larger shape. Okay, the larger shape would be 6 by 7. That would be all of this area here. And then they want to find this unshaded area here. Okay, so 6 by 7, that would give us the 42 that's here. That's a 42 there. And then the smaller area would be 2 by 3. Okay, that would give us 6. Now, why did they give us 4 here, and why did they give us the 2 here? Okay, let's look at this. So this, from here to here, this is 3, and then from this point up, that would be the 4, because 4 and 3 would make 7. Understood? And if all of this is 6, and we come here and take out 2, then that 2 would represent this 2 here as well. And then we would have 4 units going across to make this line being parallel to this line. So if we have that, then we have 42, and we're going to take away from the 42 6, and that would give us 36. All right, 36 centimeters squared. So let's come back to our shape now and see if that is correct. So 1, 1, let's go. So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So the area of the shaded portion should be 36, and our units are centimeters. So 36 centimeters squared. In this episode, we were exploring area. Now, please remember, the calculation for area is very important, especially on the exams that we have coming up. And generally speaking, people like builders and architects and so on, they must understand this concept of area. Okay, guys, take your time, pause the video if needed, go over the examples, work them out for yourselves as well, and go to your textbooks. Find other examples like the ones we have done. Do those and turn them into your teachers. Take care. I'll see you in the next episode.